Good morning, I am Ludwig Brossard from INRA UMR Pégase from Rennes. I am working on modeling and nutrition for pigs, and since for last 10 years I'm working on individual variability and since 5 years on individual variability and modeling for precision feeding. My major role in Feedogene is to work in a work package 4 for the development of some new management system for precision feeding. So in this work package we want to develop the main component for precision feeding, that is to say the decision support tools, the controlling software and hardware, and the precision feeder device that will help to implement real-time application of precision feeding in farms. The principle of precision feeding in pigs, poultry and rabbits is to adjust dynamically and more precisely to individual the feed to answer to their requirement. By this way we can reduce the feed cost by reducing the supply of nutrients. We can also reduce the environmental impact of production because of this adjustment to the nutrient requirements. The application of precision feeding requires to dispose of sensors that are able to characterize in real time the performance of the status of the pigs, and also to dispose from feed dispensers that are able to distribute feed in the targeted amount and nutrient composition. Up to now it's difficult to have a precise and dynamically characterization of animals like pigs, rabbits, or poultry because of the individual scale that is difficult to reach. And also the feed dispenser, automatic feed dispenser are now well developed for these spaces. In the work package 4, the tasks are operated in parallel for the first task. In the first task we are developing a decision support tool to calculate the nutrient requirement depending on the input from the system, input data concerning animal and feeds. In the task 2 we have developed a controlling software and hardware to make the connection between the feeder, the data inputs and the decision support tool. In the task 3 we have the development of precision feeder device to apply the precision feeding practically in farms. In the task 4 we want to connect all these elements to make a prototype that will be validated and refined with some tests in farms. And in the final task we will demonstrate in experimental and in commercial farm the application of this device with all the system combined. The expected outputs and impact for professional, farmer and advisor are to dispose of feeder devices that have been tested and that can be controlled automatically. So it's a way to put the precision feeding more easily to farmer with friendly interfaces and control. For the advisors, they will dispose from a new tool to calculate requirement and adjust also the feeding strategy to the farmers.